Welcome, students. Today we're going to talk about inverse functions. Last class we looked at one-to-one functions. One-to-one functions are special because they're functions that have inverse functions. So let's look at the definition of an inverse function. Let f be a one-to-one function with domain A and range B. Then its inverse function, f inverse, that f with a little -1 above it does not mean f to the negative first power. It means f inverse, or the inverse of f. Then its inverse function, f inverse, has domain B and range A, and f inverse is defined by f inverse of y equals x, when f of x equals y for any y in B. Let me give you a diagram of what's going on here. Let's suppose that we have a function, and the domain of that function is A. So the domain is A, and then the range is B. So we have a range of B. And so if we have a function f, and f takes the number x in A, and it sends it to the number y in B, then f inverse is defined by saying f inverse of y equals x. So what f inverse does is it takes y and sends it back to x. So the inverse function basically undoes what the original function does. Sometimes students might think of these as opposite functions in a sense because they do the opposite thing. But in math, when we use the word opposite, that usually means you put a negative sign in front of something. The opposite of 3 is -3. So we have a special word for functions, and that is an inverse. So an inverse function is something that undoes a function that we start off with. We're going to start by looking at just a couple of very basic examples, so you can see some examples of inverse functions. And then we're going to talk about how to determine whether two functions are inverses of each other. And in the next lesson, we'll look at how to find the inverse of a function. So first, let's just look at a couple of quick examples. If we have the function f of x equals x plus 2, well, this is the function that adds 2 to the input. The inverse function, f inverse of x, is going to be the one that undoes that. How can we undo adding 2? Well, we can subtract 2. So the inverse of x plus 2 is x minus 2. Hopefully this makes sense. If we have a function g of x equals 3 times x, this function takes the input and multiplies it by 3. How can we undo that? Well, we can divide it by 3. So the inverse function is x divided by 3. These are very, very basic examples because each of these functions does something very simple, like adds 2 or multiplies by 3. When we have functions that have a lot more going on, it's going to be much more complicated to figure out what the inverse is, which is why we're spreading this over 2 lessons. But I do want to look at one more example, and this example is going to cover why it's important that f is a one-to-one function. Now, if we consider h of x equals x squared, and we want to find an inverse function, sometimes students will guess that the inverse function is the square root of x. But this doesn't actually work. This doesn't work. And the reason is that if we evaluate h of -2, we know that -2 squared is positive 4. But if we try and evaluate this at 4, we get the square root of 4, which is positive 2. It's positive 2 because we use the square root symbol, and that gives us the principal square root. And this causes a problem because we need the inverse function to output the number that was originally inputted into the original function. So if this was actually the inverse function, it would give us an output of negative 2 because negative 2 was the input when we got 4. So the problem here is that x squared is not 1-to-1, so there's actually 2 different values of x that can give us 4. H of negative 2 is 4 and h of positive 2 is 4, and it's impossible for the inverse function to tell which input value gave us 4, so this ends up falling apart. So it is not true that the inverse of h of x equals x squared is the square root of x. 1-to-1 functions do not have inverses unless we restrict the domain to say we want only positives or only negatives, etc. That's something that we'll talk about later. I don't want to talk about it too much now. I just wanted to show you the example so you can see why f needs to be a 1-to-1 function. I do want to talk about one more thing, specifically regarding notation, before we move on to examining whether two functions are inverses or not. And I want to talk specifically about this -1 when we're dealing with inverses. Now, f inverse does not mean f to the -1 power. This is very important for you to understand. This -1 on top of a function is a specific notation that was designed to say we're looking at the inverse function. So when we raise something to the -1 power, that actually means we're putting 1 over it. If we had x to the -1 power, that actually means 1 over x. But if we wanted to have 1 over f of x, what we would need to do is we would need to take f of x, put the whole thing in parentheses, and put a -1 on top of it. This is an exponent of -1. This also counts as an exponent of -1. But when you have a -1 written above a function like this, this means f inverse. Over here it means g inverse. Over here it means h inverse. So it's really important that you understand how this notation works so that you don't end up getting confused. In the next video, we'll look at how to determine whether or not two functions are inverses of each other.